Jai Hind. Today the topic of my discussion is blockchain, which come under unit 4 of subject with the code KCA 101. These are the contents which I am going to cover in today's lecture. Introduction, then we will see blockchain architecture, how the transaction being added in blockchain, what are the various myths about blockchain and its limitations. So basically, what is a blockchain? A blockchain can be defined as a chain of blocks that contains information. That is, we are having information present in some blocks, and these blocks, they are connected with one another and thus forming a chain of blocks. Another important thing about blockchain, it is constantly growing ledger. That is, these chain of blocks, we could say that they form a ledger, and this ledger is continuously growing. That is, we are continuously adding blocks of information in this chain, and this ledger, it keeps a permanent record of all the transactions that have taken place so far, and it should be done in the blockchain in a secure, chronological and immutable way. In the later slides, we will see that what is the how security, chronological order and immutability is achieved in blockchain. The technique is intended to timestamp digital documents so that it's not possible to backdate them or tamper them. That is how we are maintaining a order, chronological order with them. We are maintaining it with the help of a timestamp value, and this timestamp value will help to identify that this particular transaction has been written on so and so date. It cannot be backdate, and moreover we cannot tamper them. That is, it is immutable. What's once written inside the block, it becomes permanent over there. We are having techniques for it. The purpose of a blockchain is to solve the double spending records problem without the need of a central server. Double spending means that is, we are having a currency and this currency being spent at two places. Although in physical currency case, this particular concept of double spending is not possible, because what you are having physically in hand, you spend it when you buy or purchase some service or good from a shop. But in the case of a digital money or a e-money, double spending is a problem. So earlier, double spending problem is being resolved with the help of a central authority. But in the case of blockchain, we don't have any server central authority, but yet we are able to resolve this problem. The blockchain is used for the secure transfer for items. What kind of items we could consider here? It could be your money, property, contracts, that is, or agreements, etc., without requiring a third party intermediary like bank or government. Once a data is recorded inside a blockchain, it is very difficult to change it. How? With the help of certain cryptography techniques, which we will see later on. The blockchain is a software protocol like a SMTP is for email. However, blockchains could not be run without the internet. Internet is required for blockchain. It is also called meta technology as it affects other technology. It is comprised of several pieces. Database, software applications, some connected computers, etc. This is the requirement for a blockchain to be implemented in a network. So what are the key points we had observed so far? First thing, it is a ledger. That is, it is a file that is constantly growing. Another important thing, it is permanent. It means that once the transaction is written in a blockchain, it is permanently reside over there. Secure, that is, blockchain placed information in a secure way. It uses very advanced cryptography techniques so that the information which is written inside the blockchain cannot be tampered with. Chronological means that every transaction happens after the previous one. We are time stamping the transactions. Immutable, it means as you build all the transaction on the blockchain, this ledger can never be changed. It cannot be overwritten. Chaining blockchains, how we do the chaining in blockchain. The blocks created by various miners are chained together to form what is known as a truly distributed public ledger. How the chaining being done? If you look at this figure, we are having various blocks. This is your block n plus 1, n plus 2. Now in this block we will later see that what kind of information we keep in a block, in a blockchain. These are the transactions which we write in this block. We store other metadata also in the block. For example, timestamp, as we have already discussed, that we keep a timestamp value of the transactions in the blockchain. Then we keep the nonce value. We keep you could say the block number, block ID. So these are the things which we store in the block along with transaction. And another important thing is the hash of block n. We keep this hash value. Now here we are having, or we whatever we are having here, we hash it. We use the hash cryptography techniques. For example, it could be your SHA-256 or it could be your SHA-512. Then whatever being come here, we store this value in this block. Now when we are computing the hash of this value, we got some value here again. Now this value is being stored here. That is, in a block we store two hash values. One is the hash value which we store for the current block, which we generate for a current block, and another one is the hash value of the previous block. So we have seen it. So each block in the chain contains multiple messages, and these messages, they are termed as transactions. They are, now these transactions, they are not the monetary ones, because as in the previous slides we have seen that we could create a blockchain for the money transfer, for the agreements, for property transfer and all these things. So here the transaction, it could be a ordinary message related to property transfer, or it could be a monetary exchange. A block in the chain may come from any miner. Miner is the person who is writing the block. While creating the chain of blocks, we observe the rule that hash of the previous block is added to the current block. Thus, a miner, while creating a block, picks up the hash of the last block in the chain, combines with its own set of messages and create a hash for its newly created block. This newly created block now becomes the new end for the chain. We will add, for instance, if this is the previous block, then we will add it to the chain, and thus the chain keeps growing as more and more blocks are added to it by the miners. So blockchain architecture, we can understand it with by understanding its various components. So what is a block? As we have seen, block is ordinary, you could say, location where we are keeping the transactions along with the metadata of that particular block. So the first block is always termed as genesis block. Every blockchain is having its own genesis block. Then we are chaining it with another block. Now this chaining is being created with the help of hash algorithm, then block 2, block 3 and so on. A block is a chain of blocks which contain info. The data which is stored inside a block depends on the type of the blockchain. For example, a Bitcoin blockchain contains info about the sender, receiver, number of Bitcoins to be transferred. The first block in the blockchain is always termed as Genesis. Each new block in the chain is linked to the previous block. As we can see, this is a Bitcoin block here from Sam to Peter, and this much amount is to be transferred from Sam to Peter. A block, every block has a hash value, and we can say this hash value is a fingerprint which is unique to each block. Like a fingerprint of a human being, every human being has its own unique fingerprint, and it cannot be matched with other human beings. Similarly, in the case of blockchains, every block has its own fingerprint, and this fingerprint, we generate this fingerprint with the help of hashing algorithm. It is also known as hash value. It identifies a block and all its contents, and it's always unique, just like a fingerprint. So once a block is created, any change inside the block will cause the hash to change. That is, this particular block is having this hash value, and it is for instance SHA-256. It generates a hash value of 256 bits. So once a block is created, any change inside the block will cause the hash to change. This is how the immutability has been achieved in the case of blockchain. If you change the content of this block, then this hash value automatically got changed. Therefore, the hash is very useful when you want to detect changes to intersections. If the fingerprint of a block changes, it does not remain the same block, and we termed it as invalid block because it has been tampered. So what we have seen, that each block has data, hash, and the hash of the previous block. Consider following example where we are having a chain of 3 blocks. The first block has no predecessor, and therefore it is your Genesis block. And how we have identified the Genesis block? Because its hash value is 0. Previous hash value is 0. Block 2 contains a hash of block 1. Now this is the hash of, for example, this is the hash of block 1. Then this hash value is being stored here, and now this is being linked like this way. While block 3 contains hash of block 2, hence all the blocks are containing hashes of previous block. This is the technique that makes a blockchain so secure. Another important thing is that when we are generating this hash value, we consider the content plus previous hash value, and then we compute the hash of the current block. This is just to enhance the security of the blockchain. Assume an attacker is able to change the data present in block 2. For example, there is an attacker and this person changes this data. Now this value got changed. So it changes, but block 3 still contains the old hash of the block 2. This makes block 3 and all the succeeding blocks invalid, as they do not have the correct hash of the previous block. Therefore, changing a single block can quickly make all the following blocks invalid. Blockchain follows a distributed P2P, that is peer-to-peer network. However, there is one more method which is, and this is just to enhance the security. That is, instead of using a central entity to maintain a chain, blockchains use a distributed peer-to-peer network, and everyone is allowed to join. When someone enters the network, he will get the full copy of the blockchain. And here each computer is called a node, or another name is peer. For example, in distributed P2P network, these persons, either they are termed as nodes or peer. So if you look at the figure, all the nodes, they are having same blockchain. Now if, for instance, if the attacker attacks here and it do the tampering, now this blockchain got tampered with and it becomes invalid. But at all these places, the blockchain is still intact. Let's see what happens when any user creates a new block. This new block is sent to all the users on the network. For instance, this particular person has created new block. Now once this person or this peer creates a new block, then it will send this information to all the peers who are present in the network, and they will follow certain consensus algorithm. That is, an agreement kind of thing need to be done, so that all the these are the specific consensus algorithm in the blockchain. For example, we are having proof of work, proof of stake, etc. These are just a few names for the agreement protocols which we follow in blockchain. So once a general agreement received in this network, all the peer nodes, they will add this block at their end. So this is how the blockchain keeps growing. So each node needs to verify the block. After complete checking, each node add this block to their blockchain. All these nodes in this network, they create a consensus. They agree about what blocks are valid and which are not. Nodes in the network will reject the blocks with data tampered with. So to successfully tamper with a blockchain, that if some attacker wants to attack a blockchain, then you will need to tamper with all the blocks on the chain. What it says, for instance, if the attacker is here and he is making certain updations at this particular point, then that attacker needs to make updations at all the peer nodes, and this is a very complex and very time taking task, and that is why we say that blockchain networks, they are very secure. Redo the proof of work for each block. Again, if you are tampering with, then you have to create a consensus algorithm, that is proof of work need to be done, and take control of greater than 50% of peer-to-peer network. What this particular statement imply? It says, for instance, I made some change here, then I have to make the changes at all these locations. Now there is a consensus algorithm which is playing an important role here in the network. For instance, the attacker, if the attacker is successful in making the changes at these 3 locations, but that person or attacker failed to make the updation at this location, then again in such a scenario this becomes invalid, although the blockchain here has been tampered. Why? Because in this case, blockchain case, we say if at more than 50% peers, there the blockchain is same, then at other locations or at other peers, the blockchain become invalid. This is a simple case, we are having only 4 peers, but imagine if we are having 100 peers or so, then in the case of a blockchain, we have to make the updation at least at 50 or at least at 51 peers, which is a very complicated task and it requires a large amount of processing power. After doing all these, your tampered block become accepted by everyone else. This is next to impossible. Hence, blockchain are very secure. Now, how blockchain transaction works? We request for some transaction, we do some transaction and say, okay, this transaction is to be added in the blockchain. Now, this transaction is being broadcasted to all the peer nodes. These peer nodes, here the persons, they are termed as miners. They will do the mining, they will validate the transaction, reach to a certain consensus, and after reaching to a certain consensus, that particular block or transaction added to the blockchain. So these are the steps. Some persons request a transaction. The transaction could be involved cryptocurrency, contracts, record or other information. The requested transaction is broadcasted to a peer-to-peer network with the help of nodes. The network of nodes validate the transaction and the user's status with the help of known algorithms. Once the transaction is completed, the new block is added to the existing blockchain in such a way that it is a permanent and immutable. That is, we cannot change it. Why do we need a blockchain? That is, you could say these are certain advantages, consider as advantages of the blockchain also. Resilience. First one is resilience. Blockchain is often replicated architecture. This chain is still operated by most nodes in the event of a massive attack against the system. Time reduction. In the financial industry, blockchain play a vital role by allowing the quicker settlement of trade, as it does not involve the central authority. So, there is no lengthy process of verification, settlement and clearance. Reliability. Blockchain certifies and verify the identities of the interested parties. This removes the double records, reducing rates, and moreover the transactions are being recorded very fastly. Unchangeable transaction. We have seen that once what is written in the blockchain, it cannot be modified easily. Fraud prevention. The concept of shared information and consensus prevent possible losses due to fraud or embezzlement. In logistic-based industries, blockchain as a monitoring mechanism act to reduce the cost. That is, where your shipment has reached with the help of the blockchain, it is a very, you could say, the cost has been reduced tremendously. Security. Attacking a traditional database is the bringing down of a specific target with the help of distributed ledger technology, that is DLT, which we follow in a blockchain. As we have seen that a ledger is there and it is being maintained at various peer points. Each party holds a copy of the original chain, so the system remains operative even the large number of other nodes fall. Transparency is there, that is, changes to public blockchains are publicly viewable to everyone, and therefore it offers greater transparency and all the transactions are immutable. Collaboration. It allows the parties to transact directly with each other without the need for mediating third party. It is decentralized in nature. We are having various variants of blockchain available in the market: public, private and consortium blockchain. So, as the name says, public. So, in this case, the ledger or the blockchain is visible to all the stakeholders on the internet. It allows anyone to verify and add a block of transaction to the blockchain. Public network have incentives for people to join this network and free for use. Anyone can use a public blockchain network. In the case of the private blockchain, it is meant only for the private organization, that is a single organization here I mean to say. It allows only specific people of organization to verify and that the transaction blocks. However, anyone on the internet is allowed to view. That is, you can view the private blockchain also, but you cannot add the transaction, you cannot verify the transaction, etc. For example, here we are having a department A and this is another department B, and here the things, the services are being implemented with the help of blockchain. This is a case of a private blockchain. Consortium. In this blockchain variant, only a group of organizations can verify and add the transactions. Here the ledger can be open or restricted to selected groups. Generally, in the case of the consortium blockchains, we are having the involvement of the government. Consortium blockchain is used cross organization. It is only controlled by pre-authorized nodes. This is another way of creating the different types of blockchain other than public, private or consortium blockchain. That is, we are having permissioned and permissionless blockchains. So, the basic distinction of this is from the term itself it is clear. A permission blockchain needs prior approval before using it, whereas in the case of the permissionless blockchain, anyone, any party can join the network. So, what are the various myths which revolve around the blockchain? It solves every problem, but in reality, The answer is no, because if we look at the broader way, blockchain is a kind of a database. Another myth, it is a trustless technology, but here it can shift trust and also spread the trust with the help of hashing techniques and other cryptography techniques. It is very secure. It generally focuses on the integrity part and not the confidentiality part. Yes, it is secure, but here the cryptography techniques which we are using, for example hashing, it is primarily meant to maintain the data integrity and not the data confidentiality or privacy. Some smart contracts, they are always legal, so it only executes part of some legal contracts, not all. It is immutable, as we have seen. It only offers probabilistic immutability, as I have already told that out of 100 peers, if we are able to change at 51 locations or 51 peers, then our change can become a legal. So, although we say it is immutable, but to a certain extent only. Need to waste the electricity, but the thing is now the emerging blockchains or the blockchain technologies, they have worked on this and now they are more efficient. It is inherently unscalable, but the emerging, unscalable, but now the blockchains, they are scalable. What are the limitations of the blockchain technology? Higher cost, because here the nodes seek higher rewards for completing the transaction in a business which work on the principle of supply and demand. The transaction which if we are having a set of transactions to be returned in a block, then the miners generally select those transactions which are having higher reward. So, it follows the principle of supply and demand. Slower transactions, nodes prioritize transactions with higher rewards and thus create the backlogs of transactions. A smaller ledger, it is not possible to keep a full copy of blockchain at all the peers. So, potentially which can affect the immutability, consensus, etc. if we keep a smaller ledger at all the locations. Transaction cost, network speed, because in the first or second slide I already told you that for the blockchain implementation we do need a internet. So, the transaction cost of Bitcoin is quite high after being touted as nearly free for the first few years. Risk of error is there. There is always a risk of error as long as the human factor is involved. In case a blockchain serves as a database, all the incoming data has to be of high quality. However, human involvement can quickly resolve the error. Wasteful, every node that runs the blockchain has to maintain consensus across the blockchain, and this offers very low downtime and makes the data stored on the blockchain forever unchangeable. However, all this lead to wastage because each node requests a task to reach the consensus in the blockchain network. These are the references you can go through if you want to study more about the blockchain concept. This is all about for today's lecture, that is blockchain. So, what we have learned, we had seen blocks, we had seen how the transaction is being added in blockchain, how this term chain has been implemented in the blockchain, what are the various myths of a blockchain, advantages and limitations of this blockchain. Thank you. And